Hello viewers, you're welcome back to my channel. So this video is about 10.1, which is the system of linear equations in two variables. And so here we're talking about what is a linear system, how to solve or find the solution of a linear system, and also how to determine the number of solutions for linear systems. So a system of equation that involves is a set of equations that involves more than two variables. So we said a system is linear. A system of linear equation is a system of equation in which each equation is what? Is linear. So for example, now we know that a linear equation can be written in this form: ax plus by equals to c. So if you have more than one of these equations, then it becomes a system. For example, if you look at this is equation 1, this is equation 2. Both of them are what? Both of them are linear, right? So if you have both to be linear, then you have a linear system. So it could be more than 3, it could be more than 2 equations. It could even be 100 equations, but as long as all the equations are linear, then you have a linear system. Now, talking about the solution of a linear system is, if you want to find the solution of a linear system, so you need a pair because you are in 2 dimensions, so you need 2 variables, x and y. For example, if you look at this system, here we said x is equals to 3 and y is equals to 1. So this point, 3 and 1, will be a solution, right? So will be a solution means that if you substitute, you have to check whether it satisfies both equation or not. So 3 and 1 will satisfy the first equation, because if we substitute x to be 3, because this means x is 3, this means y is 1. If you substitute x is equals to 3 and y is equals to 1, you will have 5. Also, substitute the same point into equation 2. You will have x plus 4y is equals to 7. So you will have 3 plus 4, 1, which is equals to 7. So in other words, we are going to get the same value. So 3 and 1 is a solution of this system. All right. Now, if you observe something, you will see that what? If you have a point, let's see which point is this. Let's see the point 3. Yeah. Okay, so let's see at this point, which is -1 and 2. Now, if you look at -1 and 2, does it satisfy the first equation? Let's see, if we substitute here, you will have 2 times -1 minus 2, right? Because we're substituting x to be -1, y is equals to 2. So this will give us -2 minus 4. So you see, this -1, 2 does not satisfy the first equation. But if you substitute it into the second equation, which is 2 minus 1 plus 4 times 2. So what do we get? Here you will have -2 plus what? Plus 8, right? Okay, no, I think here we don't have the second equation is just x plus 4y. So it will be -1 plus 4 times 2, which is going to be 7. So you see, -1, 2, it satisfies the second equation, but it does not satisfy the first equation. So you see, it's not a solution. For it to be a solution, it must satisfy both what? Both equations. So you can see that -1, 2 is not a solution. But which point? This point 3, 1 is a what? Is a solution. Okay. Now, let's see in general, how do we find these solutions? Or let's talk one more thing. If you look at these are linear graphs, so you can easily draw the graphs. So your solution actually is the point of intersection. So another thing we should note is that what the solution of a linear system is the point of what? It means the point of intersection. So which means where they meet, right? Now, let's look at the formal method now. For solving linear system, we have two methods we will discuss here. Substitution method and also elimination method. Now, for substitution method, there are about 3 steps. The first step is what we call you solve for one variable. The second step is you substitute into the other equation. And the third step is called the back substitution. So I'll explain this with the examples below. Now, if you look at example 1, if we want to solve this one, we want to find what we want to solve. So let's call this one equation 1. We call this one equation 2. So, you know the step 1, what does step 1 say? Step 1 say you solve for one variable, right? So remember, we're using substitution method. So here, you can already see that from equation number 2, we already have y is equals to minus 3x. So this is already good because you have one variable on one side, the other one on the other side. So let's call this one. So this is from equation 2, right? Now, step 2. This is step 2 means what? Step 2 means you substitute. So we substitute. So we substitute y in what? Now, remember, we got y from equation 2. So now you substitute back in what? In equation 1. And what does that mean? That means that we will have 5x plus 2. Remember, this is what we have. This is the equation 1. So it becomes 5x plus. Now, in the position of y, we will now substitute what? Minus 3x. And this is minus 4. So this will give us 5x minus 6x is equals to minus 4, right? And then we can easily solve for x. This will give us minus x is equals to minus 4. So what does that mean? It means that x is equals to 4. Now, this is step 3. Step 3 is what we call the back substitution. Back substitution means you solve for y. Remember, y is equals to minus 3x, right? So it means that y is going to be minus 3 times what? 4. So y is equals to minus 12. So now we have our solution, right? So what is the solution? The solution is going to be simply x is 4 and y is minus 12. So we'll say solution is 4 and what? Minus 12, right? And this we can always check. So let's do from checking here. And what is the check-in? The check-in, you check the two equations. Remember, you have 5x plus 2y. And then you will check which point. 5x plus 2y is supposed to give us what? It's supposed to give us minus 4, right? So remember what we are checking. We're checking with our solution. So you have to check the two equations. So this will be 5 times 4 plus what? 2 times minus 12, right? And you see that this is 20 minus 24, which is minus 4. So this is good. Also, we have to check the second equation, which is y is minus 3x. So this will be minus 3 times x, which is 4, which is going to be, remember, y is minus 12. So you have minus 12 is minus 12. Good. And here also you have minus 4 is minus 4. So it's a good solution. Now, let's go to the next one. So here as well, we will still use the what? We will still use the substitution method. So to use the substitution method, just like we said, we just have to solve for one variable. So it depends on which of the equation you are interested in, but you can do it from any equation. So let's say from equation 1, this is step 1 now. Step 1, you solve for one variable. So you can solve for any variable of your choice using any of the equations. So for example, if you look at question 1, you can see from equation 1, you can solve for x. You can see that what x is going to be what? 1 plus 4y divided by 3. Yes. Now we will substitute. This is now step 2. So we'll substitute x in what? In equation 2. Remember, this one we got it from what? From equation 1. Yes. So now we substitute back into equation 2. So let's write down equation 2 down. Remember, equation 2 is this one. So now we will substitute the value of x. So this will be 2y into what? 1 plus 4y divided by 3. Then plus what? 3y equals to 12. And then we can multiply everything by 3 just to clear the fraction. So this will become, so let's say multiply by LCD, which is equals to 3, right? So this will become, you will have something like this. You'll have 3 times, this is 2 into 1 plus 4y over 3 plus 3y equals to 12. Now, what this will be, it's simply what? 3 will cancel 3, so you have 2 here. So you will have 2 into 1 plus 4y plus what? 3y. And don't forget, here also we need to multiply by 3, sorry. Because if you're multiplying LCD, here you also multiply by 3, here you also multiply by 3. Because everything needs to be multiplied. So this will become 9y, and this will be 36. So if we expand now, you will have 2 plus 8y plus 9y is equals to 36. And this means 17y is equals to 34. So 8 and this, 8 plus 9 is 17y. 36 minus 2 is 34. So y is equals to 2. Right. So now that we have y, we can solve for x. So let's just complete it here. So remember, what is x? If you can see, x is what? 1 plus 4y over 3, right? So it means that x is going to be 1 plus 4 times y, which is 2, divided by 3. So x is 1 plus 8 divided by 3. So x is what? You can see this is 9 over 3, which is just 3. So what is the solution? It's just 3 and what? And 2. And then you can also check, right? You can check in the equation. And if you check with 3 and 2, 3 times 3 will be 9, yeah? And 9 minus 8 will be 1. So this is a good solution. You can check it with both equations and you'll be fine. All right. So that is it about substitution methods. So let's look at the second method, which is called the elimination method. Now, for elimination method, we say to solve a system using the elimination method, we try to combine the equations using sums or differences so that to eliminate one of the variable. So these are the steps. You said adjust the coefficient. So the idea is just to make the coefficient to be additive inverse of each other. And then you just add the equation, then you do back substitution. So I'll demonstrate this also with 2 examples here. So let's look at this one. So if you look at this now, we want to use elimination method, not substitution method. So usually what we do in this case, we call this 1, and this is what? This is 2, right? So what we are going to do is we try to eliminate one of the variables. And for example here, we will try to eliminate this variable here. Let's eliminate y. We can eliminate x, is okay. But if you want to eliminate y, it means you want this coefficient to be additive inverse of each other. And how can we achieve that? You see, we can multiply this by 5. Let's say no, by 5. 2 is better. And then you can multiply this by 5. So if you look now, but this is, you are multiplying an equation, so everything needs to be multiplied. So this will be 16x plus what? 10y. It's equals to 18. And this will be 15x minus what? 10y. It's equals to what? This should be minus 80, correct? So now you can see that the coefficients of y, they are what? They are additive inverse of each other. Remember, additive inverse means a plus minus a equals to 0, right? So now we can add these 2 equations. If you try to add, this is 10 and minus 10, this will go, right? But this is 16 and what? And 15, which will give us what? 30, 31. Yeah. Now, this side is going to be 18 and this one. So this is going to be, because we're adding, this is going to be minus 62, right? Minus 62, because we're adding, yes. Now you can see we can solve for x easily. So what is x? X is just going to be minus 62 divided by 31. So x is what? X is minus 2. Okay. So now we can solve for y. Haven't gotten x, we can easily solve for y by using any of the equations we like. So we'll say substitute x is equals to minus 2 into which of the equation? Into equation 2. And which will be 3x minus 2y is equals to minus 16. So this will be what? Minus 2 minus 2y is equals to minus 16. And then this will give us minus 6 minus 2y is equals to minus 16. So we have minus 6 plus 16 is equals to 2y. And And this will give us 10 is equals to 2y, right? And so what can we see from here? So this is minus 6 minus 2y is equals to minus 16 plus 16 is equals to 2y. So this is 10 is equals to 2y. And this means that y has to be equals to 5. So it means our solution will be just what? Minus 2 and 5. And also, just like we did before, you can always what? We can always check with this solution. If x is minus 2, 8, checking in equation 1, you will have 8 times minus 2. It's going to be minus 16. So minus 16 plus 25 is going to be 9. If you check it here, this is going to be minus 6. So minus 6 minus 10 is minus 16. So this is our equation, our solution. So then let's solve one more equation, one more system. So here, let's try to eliminate x in this case. Let's call this 1, call this 2. We'll multiply this by, we can multiply this by 5. We can multiply this by 3. So this will be 15x minus 40y is equals to minus 30. And this is going to be minus 15x plus what? Plus 12y. It's equals to 30, right? Now, once you add this and this will go. This is what? It's going to be minus 28, right? And this is going to be 0. So y itself is what? Is 0. Yes. So y is 0. We substitute y is 0 into any of the equation you like. So let's substitute in 1. This is just going to be 3x minus 8 times 0 is equals to minus 6. So this is 3x is equals to minus 6 because this will become 0. So x is what? Minus 2. So it means the solution is simply minus 2 and 0. And we can check if you substitute minus 2 here, this is going to be minus 6. This is 0 gone. So it's a good solution. We have this one. All right. So I think this is enough for this, but the first part of this video. So we will look at how to determine the number of solutions of a linear system. We will see that in the next video. Thank you for watching.